Hi, everybody. Thanks so much for joining us today for this talk. I'm Jacopo. I'm the Lead A.I scientist of Coveo. I was previously the CTO and co-founder of Tooso, an AI company in Silicon Valley that was acquired by Coveo last year. I'm going to open my presentation full screen. So today, we have a lot of ground to cover. We're going to discuss about AI in the multiverse. In particular, we're going to talk about some strategies on how we can measure ROI when A/B tests are not possible. There's a lot of things there are a lot of details that we're going to skip through today, as I believe talks are mostly for sharing ideas and then discuss at the end, and not for the nitty-gritty details when they're better shared in written form. So first, these slides are going to be public and shareable. There's a lot of links and a lot of things you can click on for details. And the second thing is that the research that this talk is based on has been published as a research paper. So if you want to know the real scientific details and all the things behind the scene, you're always super welcome to go read the papers and then get back to us and give us your feedback. We're very easy to reach. This is my contact email, and you can find me on LinkedIn. Let's get started with a particular problem, which we're going to frame it in the e-commerce world, because that's what we do most of the time, but of course is more general than that. So let's take Bob here. Bob here is having a session in a sport apparel e-commerce. Bob is searching for NBA shoes. He gets a result page. There's some NBA stuff there. He clicks on one of these shoes. He clicks on the product page of all the basketball shoes. He clicks on another shoes, and then finally he buys a slightly different pair of basketball shoes. And the question for us is the NBA shoes search, so is the search engine responsible for Bob buying the shoes in the very end? The question here is very important because all the people running an e-commerce and all the people providing service to e-commerce, of course, are very interested to know if the search engine is actually working or not. If you think of what the industry is offering, Google Analytics, Adobe Omnitor, or what people in the space are doing, for example, Rich Relevance, the answer to the Bob's question is, of course, yes. All these tools are using what is called as the presence heuristics, which is the idea is that if any search event happens in the course of a session, that search event is what is responsible for what happened downstream. So since Bob was searching NBA shoes, and at the end of the session is going to actually buy something, that NBA shoe search is actually causally responsible for the purchase. Is it though? Now take Alice, she's on the same sport apparel shop. She's searching for NBA shoes, exactly the same. She gets the same result set, and she's also clicking on one of the results set, on one of the product in the result set. However, then she changed completely her mind and she started browsing for tennis rackets. She browsed a bunch of other rackets, and she's gonna buy in the end a tennis racket. So the question for us is the search engine here responsible for Alice to actually buy the tennis racket? And of course, our intuitive answer, notwithstanding Google Analytics and Adobe Omnitor, of course, is not, right? The fact she was searching for NBA shoes has nothing to do with the fact that at the very end of the day, she actually bought tennis racket. So the first question we're going to tackle today is that what does it really mean for a purchase to be attributed to a search interaction? How can you distinguish between the case of Bob and the case of Alice? A second problem with standard attribution tool that you find in the industry is that they're not able to distinguish with different type of sales. Let's take an example from physical shops. So that's Ed. Ed is walking into a shop, back in the days when you could actually walk into a physical shop, and he has a very, very specific need. Like he wants a Nike t-shirt, cream, medium size. He goes to Assistant A. Assistant A goes into the shop and gets the shirt, and Ed is gonna buy that. That's awesome. Assistant A clearly made a good job. But then look at Assistant B. Assistant B is facing N. N walks into the same shop, and she's a bit more undecided, right? She just wants something for a party. And then Assistant B is so good at his job as a salesman that basically is able to convince Anne to not just buy a dress, but also buy shoes and earring and so on and so forth. So Assistant A and Assistant B, if you want to talk about causality, are of course responsible for the fact that Ed and Anne actually buy something. But the importance of these two assistants is very different. In the first case, we could say that honestly, almost all assistants could have fulfilled the job, right? Ed is a very specific need. He already knows what he wants. And so Assistant A is just a means to an end. Assistant B is way more creative. So he takes something that is a very generic query, and it turns it into revenue for the shop. So our second question today is, if attribution really do come in degree, how can we distinguish between great and okay impact? How can we distinguish between something that actually works super well or something that actually works so-and-so? So today's goal is to find out how to measure attribution in the case of e-commerce search as a causal effect. We need to distinguish between relevant and irrelevant effects, that is Bob and Alice, and we need to distinguish between big and small impact, that is Ed and N. No current tool really helps you do that today, and most of the industry knowledge of attribution, it turns out that is still anecdotal. Why do we want to do that? Well, if you are an e-commerce, so if you actually own an e-commerce, you want to know exactly what happens in your search journey because you want to make better decision in your digital strategy. For example, you want to decide if you want to buy a new search engine or how much money you need to invest in marketing or in a given type of funnel. If you are a company like, for example, Coveo or Tooso that provides e-commerce with search engine, you want to measure and communicate ROI. It means that when somebody buys your product, which is a search engine, you want to make sure that you can tell people how much money they're making because of their investment. And of course, on the pure data science thing, well, remember that while most people still optimize for click-to-rate is not really a good metrics for commerce. Like what we really want is not that people clicking more. What we want is people buying at the end of the funnel. And of course, if you cannot match query with purchases that are, kind of causally related, you're never going to be able to build better models. To understand a bit better why, what is the problem with the current approach to attribution in commerce, let's take a step back and go to a place when we all know very well where, what causal mechanisms are, which is drugs. How do we know that aspirin works, for example? So let's take Alice here. So Alice has a headache and it takes some aspirin to cure the headache. And it just so turned out that just after taking the aspirin, she's actually eating, spaghetti, which is her favorite meal. And then at the very end of the day, Alice is feeling better. So the question for us is, does aspirin remove headache? Well, if you think of this journey as a Google Analytics journey, the answer is yes, right? Why? Because Alice took the pill and then she felt better. This is exactly like the case of Bob searching for MBA shoes and then buying. But then, by the exact same reasoning, the Google Analytics reasoning, you also have to conclude that spaghetti removes actually headache. Why? Because, well, it turns out that, Alice actually ate the spaghetti and then she felt better. Of course, we really know that this, but there are many virtues of spaghetti, and as an Italian, you can guess that I really like them. But of course, we can totally exclude that it was the spaghetti that removed the headache, and we're kind of pretty sure that it's the aspirin that removed the headache. How are we sure about that? Why do you go into a pharmacy and buy aspirin, not spaghetti? Well, we do that with what is called randomized control trial. Before aspirin was actually sold to the public, what people did was taking two users that are basically exactly the same in all intents and purposes, let's say Alice and Ann, they go to a doctor, and one of them received aspirin, and the other of them received something that is basically contains nothing in it, let's say, just sugar. And at the end of the day, Alice is feeling better, Ann is not feeling better, and so we conclude that it must have been aspirin, the thing that actually made Alice feel better. So you have two people that are equal in all respect, one which is taking, the treatment, one which is taking something that is completely relevant, and then you're just going to measure at the very end of the day if the outcome is going to change or not. What causal discovery basically tries to do is to answer what is called the counterfactual question. So the answer for us is, if Alice had not taken the aspirin, would she still have the headache? Of course, the entire problem of this thing is that in reality, Alice did take the aspirin. So we need to find out what would have happened if she didn't do that. Let's go back to e-commerce now. So the counterfactual question in e-commerce is very easy, right? So if Bob had not searched on the website, would have still bought the pair of shoes, which is the exact same case as Alice with the aspirin, right? And you can think of approaching this in exactly the same way as you approach aspirin testing, which is, in the digital world, it's called A/B test. What is the problem with this idea? Is that you cannot really turn off a search engine on an e-commerce, because that will result in a lot of, loss of revenues and in a very, very suboptimal UX experience for most users. So ideally, yes, you can think of serving Bob as like a website version with MBA, with the search engine, and you can search for MBA shoes, and then you can add something else. But in practice, that is impossible. Think of, how much revenues, for example, Amazon would lose if they have to switch off their search engine for part of their traffic. So since you cannot really switch off the box entirely, we cannot really do like we did with the Aspirin example. We cannot really divide our group of users into groups and then measure what happens when you switch off the search engine. So the way in which we're going to frame the acquisition, and then we're going to see for the second part of the talk, and why the status quo is really not satisfying, is that when we see Bob walking into a shop in a session, digital shop in a session, so he's browsing on something, he's searching on something, what we need to do is that we need to create basically alternative versions of Bob, because Bob in reality did use a search engine, and we need to create alternative version of Bob where Bob doesn't really use the search bar, and we're going to observe what happens in these alternative realities. I know that this looks like very sci-fi and Rick and Morty, but it's actually a very intuitive way to understand causality, and we engage in this sort of counterfactual reasoning all the time. In practice, let's see what happens with a somewhat realistic session. So the orange session here, Alice on top, is what actually happened in the real world. So she's browsing in the shoe section, she's looking at a specific detail in a product, she's searching for basketball shoes, she clicks on a product, and then she buys. That's awesome. And then we have an alternative world, which is Alice Blue, like at the bottom, in a session that starts exactly like the one in Alice. So she's browsing for shoe section and she's detailing a product. But in this alternative reality, if you remember the movie from the 19th, Sliding Doors, in this alternative reality, she doesn't really use a search engine. And she continued browsing on the same website, and then she ended up buying stuff. Our way to measure how much search is important is, in a nutshell, a comparison between what really happened, so the orange timeline, and what could have happened, which is the blue timeline. Intuitively, the more these two things diverge, the more the sliding door, which is in this case the search interaction, is actually important. Of course, as we already discussed, the only thing we actually observe, so the only data that we have is Alice Orange, because that's what she did in the real world. So our question for us is, how can we create Alice Blue? So how can you create this alternative timeline that is exactly like the main timeline up until the search interaction, and then it kind of diverges? Well, the solution is that we basically build a generative browsing model, and we use this machine learning model to generate these alternative timelines. The details are a bit long for the talk, but intuitively, it all starts with what we call the product space. So if you have products in an e-commerce, you can train a model. It's called prod2vec, which is exactly the equivalent of word2vec into the product space. And you can basically map products, which are discrete entities, to a multidimensional vector space. This is actually a real e-commerce sport apparel catalog represented in 3 dimensions. Each of these dots is a product. Each of the colors represents a sport activity. As you can see here, products that are closer in the space, that are clustered together, are products with the same color. It means they're products that are basically referring to the same sport activity. For example, the violet are running products, the light blue are soccer products, and so on and so forth. Why is it important to have this low-dimensional representation of product? Well, because now you can think of a session as basically a walk into this space, right? Like this anonymous user is browsing, a pair of sneakers one after the other, and what you're having here is a path into this space. And once you have a path into this space, you can train like a deep model, in our case an LSTM, to basically learn what is going to be, given the start of a path, how that path is going to continue for another user. So once you train that model, what you're going to do is that you're going to create these 2 timelines. Again, let's take the orange timeline here as the actual world, so what actually happened, and then we have the other 2 timelines, the blue one and the green one, as the timeline that are generated by this model that we learn on real user data. So if you see here, the blue world is exactly the same as the actual world, but it diverges after the search interaction. So the user is still searching and is still clicking, but then after that, what happens is a future that is imagined by the machine learning model, is not a future that actually happened. And then you have the green timeline. The green timeline diverged, again, sliding door, like before the search interaction. If you see, in fact, here, the only thing in common between the orange timeline and the green timeline is the first section. Since we have a product space, what we can do is that we can follow the trajectory of the actual session, the one that ended up in a purchase, and the 2 simulated session. So the orange session, the blue session, and the green session. And you can quite literally visualize this into the product page. This is a two-dimensional representation just for ease of visualization. As you can see here, the actual session and the session with a simulated search ends up very close in the space, and the session that actually has no search in it ends up very far into the space. Which means, in our multiverse jargon, that in a parallel universe where Bob doesn't really search, doesn't use the search engine, he ends up in a very different region of the space. While in a parallel universe where Bob actually used the search engine and then is free to roam around, he ends up very close to what he actually did in reality. From this, we can conclude that this particular search interaction in this session is actually very important, and we can be confident that the attribution is actually causally relevant. How does a session for an easy purchase look like? Remember the example with Ed, right? Not all purchases are created equally. Take this is like a real session from one of our clients. So there's a shopper here is looking for Lakers shirts, and then he's searching for Lakers. And then the first thing he clicks after searching is actually the same pair of shirts that he was actually looking before the actual search. And then he adds them to the cart, and then he buys them. And so the question for us is, was search really important here for the user buying the shirts? It's clearly relevant, as in, the user is searching for something Lakers related and he buys something related. But if we remember the example, this looks like the green t-shirt example. Right? This is a very easy sell from the search engine. The user already really knows what he wants to do. In fact, when you actually follow this timeline and the generated timeline into the space, you see here that all these three timelines, the real one and the two simulated one, end up in basically the same region of the space. This is the mild attribution case. So on the left, you're going to see the Lakers example and how the three timelines actually goes towards the same region of the space. And on the right, you're going to see the first example, which is the high attribution case, which, as you can see, it is a very intuitive geometric interpretation of all these phenomena. So geometric intuition aside, how do we know that this works? Well, it's very hard because obviously there's no actual tagging that people have made on real session telling you this was causally relevant and this was not causally relevant. So we borrow a tool from the causal attribution literature, which is basically building synthetic dataset first to test your model. The cool thing about synthetic dataset is that since you build them from scratch, you basically can enforce some type of dependency between what people search and what people buy. And then you're going to use different methods to see if the model that you produce is actually able to capture that accurately. As you can see here, we benchmark the Google Analytics attribution, which of course is always 100% because given a purchase, the presence of a search interaction is sufficient to count that as attribution. And then different other models that interpret the attribution in a different way. The similarity model is basically just semantic similarity between search and the result. The SKU match is a rule that considers a search win only if the product that is purchased is the same one that was clicked. And of course, multiverse. After we check that the accuracy of multiverse in the synthetic case is actually fairly high, what we do is that we run all these models on real data, for which we don't have real labels, of course, because it's impossible to know what was in the hand of the user. But it's good because we have confidence now from the synthetic data set that these numbers are probably accurate. As you can see here, when you take into account a more subtle idea of attribution and not just the Google Analytics version, the importance of search is slightly decreasing. In particular, both the similarity method and the multiverse method tells you that 3 out of 4 purchases that was actually involving search are causally attributable to search. So one of them is actually kind of a spurious correlation. GA says that everything is always attributed to search, as we discussed, and the SKU match, which is another popular heuristic in the industry, is really, really, really strict. According to the SKU match case, only 50% of search-related purchases are actually causally attributable to search. So, summing it up, the method we propose, which is a deep generative model generating alternative timelines to basically assess causal importance, is able to distinguish relevant from irrelevant searches. So, it's able to actually tell us when search was important for a conversion or not. is able to distinguish easy purchases from great shopping experience. Remember the geometrical difference between the Lakers example and the sneaker example. And of course, we present it for search in e-commerce, but if you think about it, it's basically very straightforward to be extended, for example, to say a recommendation event. In particular, actually, it's straightforward to be extended outside of e-commerce anytime you have a journey of a user and you can train like a model of this user outside of what you're doing. As long as you can do that and you have a reliable way to train these models, you can always generate alternative timelines. And once you arrive at alternative timelines, then it's very easy to do the causal estimation that we propose. And again, the main takeaway message for us is that when sophisticated attribution is taken into account, 75% of the conversion are actually attributable to search, which means that compared to a naive strategy, it looks that search in this case is slightly less important than what Google Analytics will let you think, which is, again, it's very big impact, not just on people running an e-commerce, but also on people like us, which are very interested in measuring precisely the ROI of our search engine. We have to skip basically through 95% of the details of how we actually build this and make it work. But have no fear. There's a public paper that tells you all the nitty-gritty details, all the models, all the tests, all the benchmark, how to build your own synthetic data set, and so on. And of course, this is part of a bigger research roadmap. We published a lot of paper with the prot-to-vec and the whole idea of personalization. So if you're interested, my suggestion is go look them up and reach out to us for any feedback you may have. Thanks so much. I think we have a bit of time for questions, which is what I wanted. So I'm gonna close my screen and I'm gonna see if any of you ask any question in the chat, because I can see both my screen and the chat. Okay, so the first question from Devon is, I don't know if you guys see them, but I'm just gonna read them out loud. Are there application of this approach for a continuous dependent variable instead of a point of sale? Yes, I mean, in our case, so the funny thing about our case that yes, the final event for us is binary, as in somebody buys something or not, but then the actual binary event is embedded already in basically what is a dense space, right? Because when you think of the way in which you conceptualize this inference, the point is not that the user is actually buying something, but is that the user is reaching a particular point in a dense space. So it is already basically fully differentiable in the way that it is. The question is, for your case, is can you build something like an alternative timeline for your case? If yes, the fact that the final result is continuous instead of like a binary actually doesn't make much of a difference. In our case, while technically is binary as a problem, but it turns out that given the way in which we frame the problem, it immediately becomes dense. Somebody asked for the link to the preprint. Yeah, sure. We're gonna send it here. One sec. Let me Google this in real time. It's here. So this is the paper. Oh, okay. So yeah, Blair actually, yes. Blair actually, yes. Precede me. Mary asked, how does prot-to-vec handle vocabulary out of vocabulary cases where the user is trying to search for a product that doesn't exist in the prot-to-vec space? Mary, thanks so much for the question. This is actually super important. There's another research that we've been doing on how you map products that are not available as interaction into the prot-to-vec space. It's a RecSys paper of this year. I'm going to post it in the channel in 1 second. But the general gist is that prot-to-vec spaces have two problems. Not just that new products are not there, but also low-frequency products have very low-quality representation in the dense space. So what you want to do is that you want to find a way to substitute the low-quality representation in your prot-to-vec space with better representation. And the way in which we do that is basically we learn some sort of like content-based mapping between what's in the catalog, so basically text and image description, to a position in that prot-to-vec space. By learning a prot-to-vec mapping for products that are very popular, so for which the actual quality is very high, we can actually improve the quality of the product that are rare, and we can also introduce embeddings for products that have never been seen in the training set. I'm gonna share with you the paper in the channel, one sec. So Mary, this is your paper. Yes, should work. Yes, so this is the RecSys paper. If you're interested in looking up how we solve the problem with vocabulary and rare. Another question: what is the dimension of the product to vec space? How do you handle the sparsity similar to word to vec? So as for the dimension, the one that is being used in the paper, I believe it's 48 or 50. Like each vector is like a 50 dimensional vector. The number of products in the shop that we use in our network is 26,000 products, if I'm not mistaken. Like like approximate like that, and has been trained of like some millions of sessions during the year. The exact numbers, you can find them in the paper. Another question coming in: do you track only user web events as feature for your model, or do you also take into account features from other dimensions such as in-store visit or email marketing, including promos or product recommendation? Very good point from Graziano. No, as it is of now, this is just an in-session attribution tool, which mimics what, for example, Google Analytics or Omniture would do. So the point here, the unit of analysis is the session. So a user lands on a website, start browsing, start searching, and buy something. And the question is the search engine interaction related to the buying event? So there's no other feature that is taken into account. In theory, if you could find a way to embed the email marketing, for example, the wording of the email marketing in the same space as the one we're using, you can basically use the same deep generative model to go one step upstream. So you could actually ask the question of like how much the email marketing was important into the downstream visit. Mary asks again, can you please briefly elaborate a bit more on how the simulated times are produced, consider with and without a search engine? Yeah, sure. Unfortunately, it's a lot of things, so we had to skip through too many details. The gist of it, Mary, is not we don't really produce two alternative times. We produce like several hundreds of them for the different version, and then we average them out to make sure that we consider outliers. So what really happens is this: you have a session that you want to analyze. So a session contains a search engine interaction and a purchase, and then you're gonna basically feed as the first step into a new sequence. You're gonna feed the LSTM with the exact event that happens in the real session up until the search event, and then you're gonna basically let this interaction unfold for, let's say, 100 times, and then you're gonna average that, and then you're gonna do the same, but at the second time you're gonna split the session after the search event. If you've been following, you probably know that we're also gonna skip. I also didn't tell you how do we embed a search, which is a linguistic behavior, into a product space, which is a behavioral-based space. But that's a small trick that's in the paper as well. Yeah, we wanted to spend more time on the talk on the concept behind this, on this idea that attribution is really a causal inference, and that deep model can be used in a generative sense to answer this question. And honestly, there are a lot of problems that can be. I mean, the fact that we build this for e-commerce is also not a good service to the idea, which is way more general than what it is. But then when you actually have to implement it in a specific industry, like an e-commerce shop, there's a lot of details that need to be taken care of, Mary, and we explain all of that in the paper. But we wanted to give here a more general idea that may be useful also for people that are not in the e-commerce, but maybe they have the same problems that we have. They can't really do A/B test, but they still want to have a more causal understanding of what's going on. I think we still have like a couple of minutes. So if there's any more question, please let us know. I'm gonna share one more thing in the channel so that, the presentation is gonna be shared, but and you can find me on LinkedIn, but in case you're interested on the more general roadmap, not just this work, but how this work fits into our general, presentation about personalization, product space, user, and so on. I shared a very, very small blog post, which kind of recaps all the work that the team at Coveo has been doing. So not just me and Christine, which are the authors of this paper, but also all of our colleagues around the company. So if there's anything there that rings a bell, and please, again, feel free to read the paper, reach out to us, and we are super happy to have another chat about our work. So I think it's 11:35. So I wish all of you like a very good, very pleasant continuation of this beautiful talk, of this beautiful event, and have a good day. Again, if you found this interesting and you want to continue chatting, please reach out to me. We're super happy to make it happen. Okay? Thanks so much.